Across millennia, African societies mapped the heavens and measured the world with ingenuity. Their knowledge appears in bones, stones, manuscripts, and star charts handed down through generations. Mathematics and astronomy were practical sciences, critical to planting seasons, navigation, and ritual timing. These practices combined observation, pattern recognition, and systematic counting into durable systems. We will trace how instruments and abstract ideas emerged from cultural context and daily needs. Start with the artifacts, silent witnesses to complex numerical thinking and early astronomy. The Lubombo and Ishango bones carry early tally patterns that hint at counting in cycles. Repeated notches suggest knowledge of lunar cycles and simple arithmetic operations. Across West Africa, counting systems used base variants and compound numeration for trade and measures. Architecture and textiles encode fractal geometry and proportional rules grounded in mathematics. Stone weights, measuring rods, and bead systems standardized quantities for commerce and craft. Taken together, these objects show deliberate abstraction, symbols standing for numbers and relationships. Nomadic herders and settled farmers alike watched stars to mark seasonal shifts and migrations. Napta Playa stone alignments predate many known megalithic sites and align with solstices. Egyptian temples and ceilings record decans and stellar risings used for calendrical timekeeping. Manuscripts from Timbuktu preserve astronomical tables, eclipse records, and computational techniques. Observations were recorded as charts, mnemonics, and integrated into ritual calendars. These records reveal empirical methods, repeated measurement, prediction, and correction over generations. Simple sighting devices, horizon markers, and gnomons transformed sky observations into quantifiable data. Gnomons cast daily shadows to measure solar altitude and define hours and seasons. Cross-staff-like instruments allowed angle estimation between stars and the horizon for navigation. Star charts, diagrams, and mathematical tables enabled interpolation and celestial prediction. Astronomical practice combined hands-on instruments with oral calculation methods and trained apprentices. This blend of tools and technique created reliable calendars and navigation strategies across regions. These indigenous sciences influenced statecraft, agriculture, architecture, and long-distance trade patterns. Knowledge traveled along trans-Saharan and coastal routes, adapting as it met new cultures. Modern scholars uncover sophisticated computational steps encoded in artifacts and manuscripts. Recognizing this legacy reframes global histories of mathematics and astronomy. It reminds us that scientific thought flourishes wherever careful observation meets creative abstraction. The stars and numbers of ancient Africa continue to inform science, culture, and identity today.